is FX Radio and I'm Andrew Whitfield-Cook. And with me on the line today is a researcher of great renown and a career spanning a few decades, and that's Hub Regtop. So now we're going to move on to a hot topic and one that's close to your heart, and that's the use of plant extracts in combination with probiotics to create actives which have then got an additive effect or a synergistic effect with health benefits.
That's right, and that's much more in the work that I've done with urinary tract infections.
It makes perfect sense to me, that our bacterial friends, we're well versed that they help synthesize vitamins for us and protective byproducts like acetate and butyrate. But what you're talking about is something that's really quite unique and completely new, a bacterial species looking at fermenting or using herbs to create new actives in urinary tract infections.
Well, we know that cranberry competes for the site of the P. fimbriae and the type 1 pili of the E. coli.
Mm-hmm.
So we know that there is competition, in other words, and that's well known. We know that women who drink cranberry juice, if you look at the urine, yes, they seem to, on an in vitro level, inhibit the penetration of E. coli on uroepithelial cells.
Mm-hmm.
That's what we do know.
Yep.
The question mark is that we're still trying to define whether the packs are better, whether what type of packs there is in the cranberry. There's a lot of work going on at the moment, and I think Amy Howe has done a lot of work from Rutgers University in the States on the epidemiology of on urinary tract infections and recurrent urinary tract infections. I mean, the issue is that there seems to be some evidence that people with recurrent urinary tract infections, there may be some benefit of cranberry, but because everybody's got different cranberries, they have different trials, they have different compounds they're using, it's very hard to assess what's actually happening. And that came out in a Cochrane report saying that unless we start standardising a few things to know what we're working with, then we might get some proper data. But at the moment, it looks like maybe 36 milligrams of PAX, which is the procyanidins in cranberry, may have an effect. So if we go on from then we're saying, okay, we might be stopping the attachment, but what about the invasion? What about the replication? And what about all the inflammatory responses that happen in urinary tract infections? I mean, the only treatment, if you have a urinary tract infection, is there's a few things you can do, remedial things, but if it's bad, then antibiotic treatment is the way to go. Yeah. Now, the fluoroquinolones are the ones that they use at the moment, but at the moment in Australia, the resistance of E. coli to fluoroquinolones is actually about 40%.
Yeah.
So, and it's getting worse. So maybe, we should be looking at something different. Cipro, floxin, all the floxin family are the fluoroquinolones. And the first one was nalidixic acid, which was used years and years and years ago, right? Now, I'm making that statement of nalidixic acid because that stops the replication of E. coli. Now, cranberry doesn't do that, right? Mm-hmm. It doesn't stop the replication. So the combination of herbs, which, say, for instance, which we've isolated and looked at, is pomegranate. Mm-hmm. Now, pomegranate, because of its punicalagin concentration, which is the tannins in pomegranate, if you just eat pomegranate extract on its own, it binds up the protein, and that's the end of it. It goes out your poo. Mm-hmm. So you need something to say, well, okay, I want to carry it further down in my intestines. So therefore, you have to look at the delivery system. You have to look at probably a delayed dissolution thing, which I think there are capsules around now which will allow the capsule to dissolve after about 45 minutes. That means it bypasses the stomach and goes in the intestines. The other thing which is so important with that is the fact that the tannins, which are in pomegranate, the punicalagin, right, has to be broken down to ellagic acid. And that happens in the lower intestines. So you need to get pomegranate down lower into the intestines to be broken down to ellagic acid. And what they noticed was, that's great, but what other things are happening? So when you look at a longer term, as it goes further down the intestines, they noticed that all of a sudden these little compounds appear in the urine. And these little compounds, called urolitherins, which are A, B, and C, have very strong antimicrobial and anti-inflammatory activity. And they're in the urine.
Right.
And these are the observations which have just come out recently. And they're saying, well, that's very interesting because what we're trying to do is, A, produce these metabolic products from the punicalagin, right? But it's controlled by the microbiota, which means you have to have a flora in your gut which actually then breaks down the tannin to ellagic acid.
And this is where it gets really exciting because you've chosen specific bacterial species to accomplish this.
Yeah, that's right. And remember when I said about analydixic acid, which is the first fluoroquinolones which were produced for the inhibition of E. coli replication? Well, ellagic acid does the same thing, which is another major step. That here you have got high concentrations of ellagic acid being produced because you're allowing the punicalagin go deeper in the intestines. You're producing ellagic acid, and by the same time you're producing the urolitherins in your urine. So you're stopping the replication, the possibility of stopping the replication, because ellagic acid is mimicking what nalidixic acid does in inhibiting the DNA replication of E. coli, right? So you have little molecules produced in the urine, which are anti-inflammatory, antimicrobial, and you have ellagic acid working in stopping the replication of E. coli.
So what specific bacterial species are you using, Hub?
Lactobacillus plantarum.
Right.
Now, Lactobacillus plantarum works in combination with pomegranate because remember what I said to you about the tannin? The tannin has to be broken down, right?
Yep.
Because if the tannin punicalagin is not broken down, it will just go complex to proteins and be pooped out. What the Lactobacillus plantarum does, and they're very specific, it produces a tannase, an enzyme. And that enzyme breaks down punicalagin to ellagic acid. Not only that, also the added effect of the Lactobacillus plantarum is the fact that it also sits on the receptors as well. So if you have cranberry, you also have the added effect of the Lactobacillus plantarum, which is the major bacteria or probiotic, which is actually in your intestines, and it helps to sit on and inhibit the receptor sitting on your epithelial cells. So azin helps cranberry, which does a similar thing. So you've got two factors. You've got A, Lactobacillus plantarum producing tannase, helping pomegranate to break down to ellagic acid, which then itself can inhibit replication of E. coli, as well as producing urolitherins, and that's all controlled by the microbiota in your hindgut.
Yep.
So, and that's the exciting thing at the moment. That it looks like that that it covers a whole lot. It covers the attachment, it covers the replication of E. coli, and then after that, it also inhibits the inflammation, and also it's bactericidal rather than just bacterial static.
Yeah. And so any handy hints and tips for success? Like, when can you elucidate the causative agent, whether it's E. coli driven or Proteus driven or Candida driven? How do you...
Well, I think the it looks like that the biocidal activity, it can be a candida as well. It can be candida. It can be another type of gram-negative organism. It can be Proteus. It can be... But the main thing about the urinary tract infection is the fact that men have less urinary tract infection than women, and that's because the urethra, we have a little bit longer urethra than the women have. And that's why. And also, you've got to remember the anatomy is quite different in the sense of the anus being closer to the vagina and also the urinary tract.
Yeah.
So E. coli is the main one.
Yeah. And any caveats or any cautions that you'd give to the listeners, like, for instance, things like interstitial cystitis, where, a high potassium intake might exacerbate?
I think the thing that happens is you've got to change the pH around.
Yep.
That's why the urine or citric acid situation, lots of water, lots of liquid. See, the bacteria is climbing up all the time, up the urethra.
Yep.
All the time. You can't help that. So you've got to drink lots of moisture. You've got to have a large volume of urination to keep pushing the bacteria out all the time. I mean, that's an important point. Once the bacteria takes some role, then, of course, you have to have a pH issue. The replication of E. coli likes alkaline conditions. It doesn't like acid conditions.
Yeah.
Right? So there are a couple of issues, as well as, of course, the protection that you have. And the other story which I haven't talked about is the fact that they're finding out that vitamin D has a role in the uroepithelial control of microbial bactericidal activity.
Now, this is with regards to the cathelicidin LL37, is that right?
That's it. Yep. That's it, yes. And they've shown that women who take vitamin D as compared to women who do not, the cathelicidin levels are quite low in women who don't take vitamin D.
Yeah.
And, of course, when you have an infection, the cathelicidin's concentration goes up. But if you can't produce any more, because you have to genetically synthesize the cathelicidin. So, in other words, vitamin D activates a gene, which then activates the synthesis of cathelicidins. So, and that's what they've shown, that once you increase the cathelicidins in women, you have a bactericidal effect. In other words, you're killing the bacteria. You're just not inhibiting its lodging and sitting on the membrane. You're actually killing the bacteria.
So just to recap, with women who have got recurrent or urinary tract infections, and certainly recurrent urinary tract infections, so lots of water, cotton underwear, wiping front to back,
pH.
Balancing your pH, and taking a supplement like a ultrabiotic UTI, urinary tract, urinary care.
I think definitely the combination of, if it's available, the pomegranate and lactobacillus plantarum story, because the lactobacillus plantarum will keep a normal growth going, and the microbiota, which is controlled, rather than if you have amoxicillin, you immediately will probably end up with a urinary tract infection because your vaginal flora changes. And the moment your vaginal flora changes, you tend to get, your tendency to get a urinary tract infection is much higher. So that's why they tend not to use amoxicillin in the treatment of
urinary tract UTIs.
That's right.
So taking a product like ultrabiotic urinary care and making sure that they get enough vitamin D, whether that's from sunlight or a supplement. And I think the last you've got to get it from a supplement these days. Yeah.
I mean, if you look at the vitamin D people who say how much sunlight you need, and once upon a time they said that you need to be 10 minutes in the sun. The latest interview was, I was saying that in the summer, yes, 3 times maybe a week, when they're talking about exposure, they're talking about a total naked body. They're not talking about just arms and legs. And they say 10 minutes. Well, that means total nakedness. In the winter, what they're saying now, well, it's very difficult because the UV is not as high, and therefore you need maybe a longer exposure. So it's becoming now difficult to say, well, you get enough by sunlight, you might get a spike, you might get a peak of vitamin D, which is high, but can you maintain it? You go to the sun every day. So the thing is, I think supplementation, you got to remember also, coming to the vitamin K story, that the production of osteocalcin is regulated by vitamin D. So if you want increase in osteocalcin, you need vitamin D. But the osteocalcin may not be active until you carboxylate with vitamin K.
Right.
So vitamin D and vitamin K, they go together, hand in hand.
Yeah. So I think one of the last caveats is any progression of symptoms in especially a woman with the urinary tract infections, like, for instance, blood in the urine or Rigor's back pain, that sort of thing, fevers, chills, then, that warrants medical intervention then, obviously.
Oh, absolutely. Absolutely. See, what I'm hoping is now that these concepts are coming up, because we need to have a bactericidal effect. We need to stop the replication. We might be able to stop the invasion. We need to stop the replication of E. coli. And then we need to stop the damage that it does in the sense of the inflammatory responses, because the pain and all the other exfoliation that you're seeing is due to the uncontrolled body responding to an organism, which is saying, well, there's an inflammation going on. I have to respond from an immune point of view. So if you can overcome all that, in other words, stop the invasion, stop the replication, and then these products might actually work from the time when you actually get the infection, rather than trying to work on people with recurrent infections.
And I think you've just recapped the major use of ultrabiotic urinary care in that one sentence.
That's right.
Yeah. It's antibacterial action. Hub Regtop, I thank you so much. Your career has spanned so many decades. You've done so many things in your career, and it's of great interest. And I really thank you for this recent research that you've done, say, in the last decade or so, on vitamin K2, MK7, and also, I think from a practical level, the work that you've done with bacterial species using herbs to activate, if you like, certain biochemical entities. I think that's a real winner for the market.
We got to understand, the metabolism of these herbal compounds, and I don't think we've evaluated it properly in the past. I think we're starting to see now that we need the bacterial microbiota we have seems to be linked much more to pathology these days. If you're looking at wild autistic children, why do they have a different, say, for instance, microbiota than normal children? Why is the microbiota in different pathology so different to humans? I mean, is our diet changing our microbiota? Is from a nutritional point of view, is our intake of food so different that we're constantly interfering with our normal microbiota in our intestines, which is really replicating and modifying our chemistry, including brain chemistry.
Hub, thank you so much for joining us on the line today. Really appreciate your time. Thank you.
Okay. Thank you.
This is FX Radio, and I'm Andrew Whitfield-Cook.